The first one we have is from Terecircuits, when Rickard, the CEO, will talk about the novel materials for microLED transfer and processes. Um, and I'll let you begin, Wayne. You can have the stage.
All right, thank you, Ron. So Terecircuits, just a little bit about who we are. First, we're a material company, primarily chemists and process engineers, and we're focused on the advanced packaging space. So that includes micro LEDs, but it also includes other areas in semiconductors, including 3D chip stacking and chiplet assembly. We have a very unique material called terafilm that I'll be talking about, which is a photochemically activated material. And the idea is that it's specifically engineered to handle components that are thin, small, and fragile. Micro LEDs fit right into that category. One of the other unique things about our company is that we work very closely with tool partners to optimize the total cost of ownership of their equipment, which is one of the big factors when you're scaling up a new technology. So we were founded, the first IP was developed by our founder in 2003. So a long history of developing this technology. We were incorporated in 2015, and then we began raising money in 2019, about 5.4 million US dollars to date. And that's allowed us to focus on both the micro LED market and advanced packaging and assembly for semiconductors. So we're a U.S.-based company out of Mountain View, California. We work very closely with tool partners and display partners in the U.S., but we also have quite a few partners and evaluators in Europe, as well as in Asia, and where we also collaborate with A-Star in Singapore on some advanced packaging initiatives. Our market approach is to focus on our technical specialties, which include materials for placement packaging, interconnects, and specifically, as I said, focused on semiconductor and display manufacturing, but also with a feedback loop with the equipment providers so that as we understand how the tools are being used, we can optimize the material. And again, there's a feedback loop where the material advises how the tools can be optimized. So as a result, we end up working with a lot of the main tool vendors that are working in the space. And we also work with some of the OEMs directly who are building internal pilot tools. We have two main categories of product. The first is our polycarbonate photopolymers, which I mentioned, that's terafilm. And we're also introducing this year a new product, which is a nanoparticle infused composite for underfills and encapsulation, where we can match the coefficient of thermal expansion of the materials that we're working with. So Terecircuits has 7 granted U.S. patents. We have 7 additional provisionals that have been filed. And we do have some that are actually expiring, and they are being refreshed with new filings in 2021. So a very strong IP moat around our technology. So getting to micro LEDs and how we play, you can really look at the micro LED panel space as having almost like in semiconductors, a front end and a back end. And the front end is focused on the epitaxy, getting the micro LEDs themselves manufactured, growing them on sapphire, and then getting them to have the right characteristics so that they're self-emissive. But once they're manufactured on the epi wafer, they need to move to the back end where they need to be singulated. They need to be carried onto some type of a carrier and then transferred. Any case where you're doing pitch conversion, there's going to be a realignment of those micro LEDs and also a transfer from a substrate from a carrier to a substrate. So this is the area where our materials come into play. And just to talk a little bit about the challenges with micro LED displays, today an epi wafer can produce a micro LED about 34 by 58 microns. That will allow you to build 1 to 4 displays. This is data from Yole. And when you look at that density of fabrication, you see that the 2024 cost of material, of micro LED material, is over $7,000 just in the material